welcomed by the attendees at this time of the day. Okay, fine to go. Okay, hi everyone. Welcome to MEV Nethermind in Eth2. And we have Marcello Bardus, who is L2 researcher at Nethermind, and myself, Tomasz Stanczak. And I work on protocol engineering in Nethermind. So maybe as a quick introduction, what is Nethermind? Nethermind is Ethereum client. It supports mainnet. It supports XDAI, sidechain, POA, energy web chain, sidechains. It supports all the test nets. It supports all the latest forks and the future forks, I think, as well. MEV itself is the infamous miner extractable value, so the way of introducing solutions for on-chain arbitrage, but the one that is very naturally available to miners, mostly because they are always the first ones to react. Like based on the way the consensus is designed, miners are always the first ones to get access to whatever information is in the mempool and will be included in the next block. We show some of the tooling that we built around some other solutions available, like flashbots, that allow to use Nethermind as a tool improving MEV, and we'll also show the solutions for MEV in Ethereum 2. And Ethereum 2 itself, let's introduce it once again. So it's a proof-of-stake Ethereum that will happen after the merge itself being this big event of bringing Ethereum 1 execution layer and Ethereum 2 Beacon chain consensus layer together. The first DevNet of the merge was done successfully around May this year. During the ETH Global Hackathon, it was the event called Rionis, which was like side events to the hackathon, and we had multiple 7, I think, Ethereum 1, Ethereum 2 clients operating with this new approach, this new very simple, fast way of showing that there is some proof of concept for Ethereum 1 and Ethereum 2 clients working together. And Nethermind added this merge support as a plugin, as a consensus plugin. I'll talk about it a bit more later. So why MEV in Nethermind in Eth2? Because practically when Nethermind was created a few years ago, it started not really as a client implementation, but it started as a vision of building a set of tools for DeFi, for experimenting with the extracting data from mempool and so on and so on. It ended up being a much bigger project than just what it was meant to be as a just quick experiment of what the clients do. And ended up being a full client, but what stayed in the head and in the culture of the company was that DeFi will be a big thing, and Nethermind should support DeFi and MEV and arbitrage because this will be big on Ethereum. And the 3 big plugins that we'll talk about today that are available in Nethermind are the MEV plugin, so the implementation of, so the same thing that you know from MEV Gav, for Flashbot's implementation of Gav that allows the bundles to be delivered, the arbitrage bundles to be delivered to Gav miners. The same thing we built for Nethermind, which is important in a way that it enables additional side chains to enable MEV. So for example, XDAI uses PostDAO consensus, which is not supported by Gav, which means that with Nethermind MEV, we have XDAI enabled for MEV. We also built the MEV Searcher plugin, which is like work in progress build-up of a plugin that allows to execute some operations of pushing the bundles to the relayers. And finally, the merge plugin itself that I mentioned was built as a consensus plugin. So all of those things come as external implementations of, like, okay, we build them ourselves, but you could easily build them just with the API that is available in Nethermind.
Okay, so in the context of MEV, it's really important to mention how a block is created. So let me quickly remind how it happens now before the merge. So basically the flow starts when a user sends a transaction. That transaction ends up in the Ethereum 1 client mempool, then it's propagated through the network, and then finally one of the clients creates a block, and whenever it wins the proof of work, that block together with the transaction ends up in the chain. So that's how it works now. And how about after the merge? It will be similar. So the flow will be that The user, again, will send a transaction. That transaction will be propagated in the Ethereum 1 client. Then it will be propagated across the network, end up in a pool, and a block will be created. And that block will be passed to the Ethereum 2 client, and then it will be included in a beacon chain, and a consensus will be done on top of it. Also, what is important to mention, that on Ethereum 2.0, the next block producer is known. Okay, having that said, let me introduce one of the solutions for doing MEV on Ethereum 2.0. So this solution basically is copied from Ethereum 1, and the design is really similar. So we have searchers on one side who find MEV opportunities, send them to the relay, and then the relay sends them filtered to the Nethermind Ethereum 1 client, and the Ethereum 1 client creates a block and sends to the Ethereum 2.0 client, and the block is created. And what is important, that the revenue is split across the Ethereum 1 operator, the staking pool, and the validators. And that solution was created during the Scaling Ethereum hackathon together with Nethermind, Lido, and Flashbots. And also there is another approach, and I will let Tomasz introduce it.
Yeah, so well, in this solution one, we have this equal split between the stakers, validators, and the node operator. It's a simplification, but it's actually simplification of a very important concept, something that's still in research. So what we still think about is, in Ethereum 2, who exactly has the biggest power in this market of who gets the MEV? Is it the searcher? Is it validator? Is it staker? Is it if1 node operator? Is if1 node operator the same actor as the validator, or are they actually split? So you would have maybe Infura delivering nodes for Bison Trails or for Lido. So there's lots of questions here. And this was our first exploration, as Marcello said. And the second thing is something quite new that was discussed with Flashbots and is based on some ideas that were brought by Jason Periani and then explored by Alex Abadia. And then we arrived at this carrier transaction design. And what the carrier transaction is. And the whole thing is how to use mempool to distribute the bundles, the MEV bundles, because if you are aware how the relay works nowadays with Flashbots, is you have to connect to relay via like some kind of JSON RPC interface, and the relay then passes it again to the miner. So there has to be this kind of centralized managed connection between the miners and the relayer, and the bundles go there this way. So how could we decentralize it and prepare for Ethereum 2 the direct delivery from the searcher to a particular validator that we know in advance will be creating the next block? And the initial idea was there that we can use the mempool. The question was how. And first we thought we should create a special transaction type. There is EIP 2718 in Ethereum, and it allows you to build new transaction types. But even as we design the new transaction type, there is a requirement for a consensus change. So all the clients have to support decentralization of those transactions, have to recognize those transactions inside the blocks, and so on and so on. So can we do that without any changes? And the answer is yes, with this simple design of carrier transactions that are entirely normal. They have the from sender address, they have the nonce that is a valid nonce, the next nonce for a given sender. They have whatever the to recipient address is in the transaction, and then they include a call data or like data field inside the transaction that contains the encrypted serialized bundle of other transactions. So they are carriers of this content of a MEV bundle internally. And why is it encrypted? Because we were thinking about the solution that is targeted at particular validators. And let's see how the architecture of this looks here. So a very important part of this solution that was suggested by Alex Abadia was the validator to the block builder registry. So we could require the encryption with the validator keys but maybe it wouldn't be the nicest thing. To reuse the validator keys to decrypt the messages are just not so neat. So instead, the validator can delegate a block builder of their choice. And it doesn't have to be a single block builder. It can be many of the block builders that are approved by the given validator. So we can look at who is producing the next block on Ethereum 2 network. Is it this particular validator? Then check up in the registry what block builders are available, and then also analyze how those block builders behave, and then as a searcher, I can encrypt with their keys and then distribute over the network. And I know that it will be delivered to those block builders, and I don't have to have direct connection with those block builders. So from the registry, I don't have to collect information about the node on the network that I have to connect to. I say, okay, this is what I encrypted with, and I distribute it using the standard P2P mechanism. So why this P2P delivery is guaranteed? Because if we include the valid from address, valid nonce, and valid payment with the proper gas price, then this is a transaction like any other transaction. If we start thinking of potentially censoring this transaction, there is nothing that restricts us in trying to hide it the same as any other transaction. And censoring on the peer-to-peer network simply shouldn't work because there is enough of various paths and disconnected subpaths, subnetworks, subgraphs that can deliver anything that you want to censor. Why the block builder is construction is important apart from the fact that we simply want to use the P2P. Because validators already mentioned that they would like to have ability to define a bit more in details how the block is constructed. The validator operators are quite big now, and they're already planning how they monetize those solutions, how they actually deliver blocks that satisfy their requirements. And those requirements might be not necessarily simple standard block, but maybe they want to include some transactions of their partners, maybe they want to include MEV, maybe they want to include more MEV, less MEV blocks, and so on and so on. And yeah, that's what I wanted to show first. So we can define the block builder recipe, like the definition, very simple definition of how given block builder constructs the block. And we can say there are simple sections inside the block space that tell us there will be MEV, and it will be on the second position just after some partner of ours, maybe some layer 2 transactions batches that come and have to be guaranteed that come in the block. Then maybe there is a standard public mempool set of transactions, and maybe another layer of, for example, Flashbots private, which is not necessarily MEV, the one that is front-running everything else, but the Flashbots transactions that are, or any other relay transactions that want to be private, but they don't want to pay for being first in the queue. And this is just an example that can be expanded, and we can start saying, okay, we build a market and a set of definitions that allow searchers to check if they want to work with the given block builder, validator to define if they accept the given block builders competing on who is the most efficient one, so they are being actually approved, selected. And sometimes this connection between the block builder and validator might be very strong in a way. It may be the same entity, and I may want to say, oh, this is my validator, this is my block builder, and I want to capture the MEV myself. And suddenly, as a reasonably weak validator, I can actually build any MEV capturing. But I can also delegate it to some stronger operator. And if you go back, so there are really two ways of providing support for sending those carrier transactions. So the simpler one, like the more obvious one, it's not here. It's something that would be built into the Ethers.js provider for Flashbots. And you simply have the way of sending carrier transactions. You provide the bundle, you provide the account that you want to send it with, and you say, send it as a carrier transaction. And here we have an example of how it would look inside Nethermind in our prototype that we have with publishing it over JSON RPC. So if we don't send it as a raw transaction already signed, we can say, send it for this particular validator, or like this registry validator, block builder. This is my transaction representation of a carrier transaction to carry information about the sender, nonce, and so on, and there is a bundle to encode. And then we simply encode this as RLP. We use some potentially like the asymmetric cipher to encrypt. Then we construct the carrier transaction and send it. And send it whatever way we normally send transactions to the mempool. So it doesn't really differ much from publishing the standard transaction on the mempool. And from the perspective of the node that is a miner or validator node, the one that constructs the blocks, the incoming bundles can come either from Relay or from the mempool. And after they are processed and go together to the same pool of bundles of the MEV opportunities, they are treated exactly the same. There's no difference in how the transactions, the bundles, arrive to the node. What happens next is the standard scoring, like ordering by which is the best MEV opportunity for me as a miner, validator. How much am I paid? How much my revenue is increased by the fact that I'm including those transactions, those bundles inside my block. And whether it comes through Relay, mempool, or some direct creation from my local MEV, doesn't matter. And why, for us, the MEV and XDAI is particularly important? So we are now finalizing the work on preparing MEV Relay to deliver the messages to XDAI validators. We run our own XDAI validators as Nethermind. And there are also other Nethermind nodes being used as validators on the XDAI network. And since this is a proof-of-stake network, it acts as a fantastic testing ground for the proof-of-stake approach for MEV. Like, okay, how it will behave if you know validator X seconds, X minutes in advance. At the moment, I think XDAI has something over 20 validators generating blocks every 5 seconds. So you have around 2 minutes before the block happens to know that particular validator most likely will be creating the block. And then you can use all these encryption mechanisms and you can test. And since we already have prototype and another one should be coming soon in GEF, it will be a nice playing ground for testing both the carrier transactions and MEV in sidechain. And since when we think about MEV in Eth2, we think about sharding as coming after the merge, and we think that the sidechains will actually be natural candidates for the shards. So any testing of the MEV in particular sidechains leads to potentially cross-shard MEV in the future.
Okay, also, as rollups are known to be a scaling solution for Ethereum 2, we'll introduce them and describe what kind of MEV can happen there. So let me quickly introduce what a rollup is. Can we switch the slide? Yeah, so rollups are a way of executing transactions outside of layer 1, but the data is posted on layer 1. And by having that said, the data is available in layer 1, so also the state of the rollup can be recreated, even if the operator turns off. And what is also important, rollups have an operator, which are also called sequencers. And those rollup have a contract, and basically the state transition of the rollup is secured by the contract either by validity proof in case of zero-knowledge ZK rollups, either by fraud proofs in case of optimistic rollups. So optimism is obviously the most known optimistic rollup, and there are various ways of mitigating MEV, for example, by MEV auctions and using fraud proofs. Yeah, it's for proving that the transactions are valid, and also the transactions are posted on layer 1, and there is a way to speed up the execution by posting it directly instead of going through the sequencer. Instead, Starknet relies on validity proofs. Basically, whenever something happens on the rollup, validity proof is posted on layer 1, and on layer 1 there is a contract that relies on zero-knowledge proofs that verifies that the state transition was valid, and all of that happens on layer 1, but the blocks, the layer 2 blocks, are proven by the sequencer.
And when you think about layer 2 sidechains and Eth2, this is how we see Nethermind is actually combining or gluing all the different directions where Ethereum ecosystem is going. So we see Nethermind as a bit more than the mainnet. if sidechain is based on Ethereum, if layer 2 is interoperating with Ethereum, if Ethereum 2 is the next step for Ethereum, then this is what we want to have interoperating for efficient MEV, but for efficient execution in general. So whatever actually constructs the new DeFi markets, we'll be using in the future all of those components working together. So if we think about Ethereum 2 scaling, and there is interesting realization that when we were going first towards Ethereum 2, we were asking questions. Ethereum 2 will provide sharding, it will scale the system, it will provide proof of stake, it will provide finality, and so on and so on. And then we realized, okay, but what if scaling is not the biggest problem to solve by Ethereum 2? What if scaling is solved by actually using the layer 2 solutions? Then layer 2 solutions may make the problem of transition to Ethereum 2 much, much simpler, right? And I think this is the direction that we see now. Like, use the optimistic rollups, rely on the ZK rollups for scaling initially, start working on sharding. The sharding will be coming as a next step. In the meantime, transition to much safer and much desired and much anticipated proof of stake on Ethereum. And then introduce the like when we think about Nethermind, just use the fact that we are positioned in all of those different side chains, that we're working also with the layer 2 providers together, and that all of those solutions can together provide potentially either multi-chain MEV or cross-layer MEV, and all of that can come with the additional tooling.
Okay, let me also introduce the sequencer role, as said. So basically, on layer 2s, the block is produced by those sequencers, and they either accept the transactions directly using like JSON RPC or any other kind of API, but either by posting the transactions in layer 2, and very often, for example, on Optimism, the sequencer must include that transaction in the layer 2 block, otherwise a penalty will be given to it. And also, right now, most of rollups operate either in the single sequencer model, either in the multi-sequencer model. And any kind of MEV that creates, it happens on layer 2s, can happen by posting L2 batches on layer 1, and those actions can be front run or any kind of MEV can happen there.
What you wait. Yeah, so like when you think about the sequencers, so there was a big exploration of the sequencers for like how do you prevent MEV in sequencers? How do you use sequencers for MEV? And different layer 2 solutions have different approaches, right? So when we think about Starknet, Starkware, so they were working on VDF solutions to ensure that the ordering of transactions is predefined and that there is no shenanigans on reordering transactions just for better MEV extraction post factum. So all the transactions will be ordered based on some VDF-defined numbers, hashing, and then you can no longer change it when something new arrives. And this, for now, I think it's just on the side, and that will come back probably. So look at this VDF solutions inside Starknet. As for the Optimism, the current sequencer solution there is centralized, right? So we know that practically all the MEV goes to layer 2 operator because they run the sequencer, and I think this will be happening for the foreseeable future for all the L2. Why we think so? Because the L2 mostly will care about delivery of the main business of scaling and delivering the solutions that are verifiable in layer 1, and only then will transition to democratizing sequencers and solving those issues that are there somewhere on the edges of their domain. And those sequencers that can be further democratized will probably use some of the tooling that the teams like Flashbots, the teams that work on MEV nowadays, will be working on solving. But in the meantime, I think that recently we had the announcement from Optimism saying, okay, our sequencer will be centralized at the beginning, but we'll just use this as an opportunity to support this retroactive public goods funding, right? So I think that layer 2 solutions are aware that there is a big question about what they will do with MEV. Like, are you doing layer 2 thinking that this is the monetization solution? Is it centralizing all this value extraction? How much value will be flowing through layer 2? So big questions to come. Also, when you, sometimes we have those questions about side chains, layer 2, is the MEV there much larger in scale than on mainnet? Obviously no, but will it be larger or will it be large enough? And we think that everything grows together, the scale, so mainnet will always carry the biggest value and maybe not biggest volatility, the biggest value transactions, and that will actually lead to huge MEV opportunities whenever the markets get more volatile. But as for the layer 2 and side chains, they'll keep growing, and at some point they'll be more and more significant for more searchers, more bot operators. And we already see things, some bot operators working on Polygon, starting to work on XDAI, probably preparing for the cross-chain, cross-layers solutions. Fantastic. Thank you so much. So these are our handles, and then we'll be very happy to hear questions from the audience.
Whoever has questions. Yes. Okay.
So with this carrier transaction, does the searcher run the risk of just having the transaction be inserted on chain and just pay the price without actually getting, the real transaction inserted?
Hello. Yeah. So this is a valid question, right? So will you as a searcher end up paying? And the answer is yes. And we also say one of the reasons why it was not possible to decentralize the relayers properly so far was that there is this denial of service attack vector when you're sending too many bundles and nobody is paying for them, but they require simulation, they require scoring, and you don't know upfront how expensive they are, if they're using some tricks, and so on and so on. With this solution, you can establish some level of trust that if you deliver this transaction directly to, okay, so you can use Relay, you can use the P2P layer. And on P2P layer, the block creator can either discard the shell of the carrier transactions and just include whatever it's inside, or they can always include the shell as well, and you end up paying for your bundles that you deliver. So you have a payment model, might be quite expensive, to deliver MEV. But usually for efficient MEV, you'll be expecting that the content will be much, much more valuable than the shell itself. When you start competing with other searchers for similar opportunities, then you may end up paying a lot for the same thing and losing to others. But not necessarily you can have miners or validators trying to punish you for that and always include those carrier transactions, the shells themselves, because maybe there might be some kind of social consensus that we know it was just a shell, there was not malicious behavior, we have it as a potential slashing punishment of like, okay, you didn't send anything valuable, or the bundle was trying to make us process too long, and then you end up paying. So that's the expected mechanic and dynamic behind it.
So will Ethereum 2 mitigate in any way the layer 2 transaction censoring?
Can you repeat maybe?
Yeah, like with Eth2, will it mitigate in any way the L2 transaction censoring? Censorship. Yeah, censorship.
That depends, because as on Ethereum 2.0, the validator is known, but also there are validators that are chosen randomly. It's harder to organize such a censorship.
Okay.
I think also have one more thing that I forgot to mention, but it's a bit of an answer to the question before. So we were asking about inclusion of the carrier transactions in the block. So when they're included, then they disappear from the mempool, but they still can be read by the validator creating the next block. So we think that actually like this two sources of delivery of transaction on bundles become like free sources really. One is from mempool, the encrypted ones, then there is a relay like direct JSON RPC connection, and the third way is by extracting it from some of the previous blocks because they may have been included as valid transactions, and we just see that, oh, the data content of this transaction, we can extract from them the MEV bundle that is addressed to us. And we do that with this encoding of the prefix telling this is MEV transaction and then the validator public key, so I know it's for me, and then I can decrypt it so I don't waste decryption time on the keys that do not belong to me. Any more questions? Don't be shy. Yeah, thank you so much, everyone. Thank you, Marcello.